Hello, good afternoon everyone. How are you all? 1 second, let me check if we are live, and I think we are. 1 second. Yes, we are live. So how, yes, anyone here? Yes. How did your physics exam went, bachas? Tell me, huh? Okay. Yes, sorry. Okay, what happened? Okay, so my dear students, how did your physics exam went? How did it go? Okay, so I had a doubt actually if most of you took your phones with you or not, because I think you have some time now, right? Yes, okay. So anyone out there? How did your exam go? How did your physics exam go? Give me a thumbs up or any sign that you are here so that I can start the revision, the final revision. Not good? Okay, don't worry, it's okay. You have chemistry, you have maths, you have biology, hai na? So it's not just physics. So don't let that one paper, ma'am, we don't have much time. Please start soon. Okay, sure, we'll start soon. Okay, sure. So let's start the revision. Yes. So again, question about bond order. We are asked to arrange them in increasing bond order. Then remember, whenever you have 14 electrons, in that case, the bond order will be 3. In that case, the bond order will be 3. And if you increase or decrease the number of electrons, like 15, 16, 17, in that case, your bond order will also decrease by 0.5. So it will be 2.5, 2. 1.5, right? Similarly, if you decrease the electrons, 13, in that case also 2.5, 12, in that case 2, right? So in increasing order, first you calculate the number of electrons of these, okay? And then you see, for carbon it's 3, 2.5, 1.5 and 0.5. This is the one trick. Yes, I know time is running, that's why. Okay, so the trick that you should remember is that whenever you are approaching these kind of questions, take 14 electron as your reference. 14 electrons means the bond order is 3. If you increase the number of electrons or you decrease the number of electrons, then bond order will also decrease by 0.5. Hence, this is the order of increasing order of bond order, okay? Because C2 2 negative 14 12 plus 2, 14 electrons. It has the maximum bond order. Next question, pick up the incorrect statement. So see, dipole moment of ammonia is due to orbital dipole. So orbital dipole is nothing. Orbital means the lone pair we have, right? The lone pair we have, their dipole moment is called orbital dipole moment. This dipole moment, the lone pair dipole moment is called orbital dipole moment. So it is due to the orbital dipole moment and resultant dipole in the same direction. So see, in case of ammonia, all these 3 NH bonds are pointing in the same direction, right? So that means the dipole moment gets added up, and this dipole moment is also in this direction. Whenever you have any lone pair, the dipole moment will always point in that direction, right? So the resultant dipole moment, yes, is in the direction of the orbital dipole moment. Same, correct statement. In BF3, the bond dipoles are higher, but the net dipole moment is 0. That is correct. Why? Because in BF3, all these 3 bonds have dipole moment. All these 3 bonds have dipole moments, but the resultant is 0. Why? Because due to these, the dipole moment due to these 2 bonds cancel out due to this one bond. Okay, so that means this is also correct. Dipole moment is a vector quantity, yes, because dipole moment has a direction and magnitude. O2H2 show bond dipole moment due to polarization. See, due to bond dipole moment means there is a difference in electronegativity between 2 atoms. Boron and fluorine, they have electronegativity difference, but in case of oxygen and hydrogen, both have same electronegativity. Okay, so if there is no electronegativity difference, there is no polarization, there is no bond dipole. Clear? Okay, next question. The pair of species that have same bond order, again count the number of electrons, same number of electrons, same bond order. Simple trick, same number of electrons, same bond order. Okay, we are not asked a specific bond order in this one, so same number of electrons will have same bond order. Okay, so in this case the answer is A, because CO and NO positive have same bond order. Remember, some of you were asking that. So whenever you have a minus charge, whenever you have, let's say you have NO negative, so whenever you have a minus charge, you add that charge, and whenever you have a plus charge, let's say for some chance you have CO2 positive, if you have O2 positive, so you just subtract that charge. How much charge is there? You just subtract it. If it is minus, you add it. If it is plus, you subtract it. Remember that. Okay. Next question, in which of the following pair both species have sp3 hybridization? So there are two formulas to calculate hybridization, and we'll go by the majority one. So hybridization is number of sigma bonds plus number of lone pair. Number of lone pair of electrons? No, number of lone pair. How many lone pairs are there? One lone pair means 2 electrons, right? So for example, in case of NH3, how do you calculate the hybridization? Very easy. Number of sigma bonds, how many sigma bonds it have? 3 sigma bonds, 3. How many number of lone pair? Lone pair is 1 lone pair is there. Electrons are 2 but lone pair is 1, so 3 plus 1, that is 4. 4 means steric number 4 means 1s and 3p, 1s and 3p, that means the hybridization is sp3, that means the hybridization is sp3. Okay, clear? Now see, one more method is there just for some of you if you use it, that is half number of valence electron of that atom plus number of monovalent atom. Monovalent means the atoms that have valency 1, okay, that form only one bond, okay, minus the charge of cation. If you have plus, again the plus charge means cation, right? So you subtract that charge, and if you have any negative charge, anion charge, you add that charge, okay. This will also give you a steric number. In this formula there is one more thing that you don't have to remember the structure. Okay, next question, which of the following ionization process changes from paramagnetic to diamagnetic? Paramagnetic to diamagnetic. So it is only one case, this one. So when we are talking about paramagnetic to diamagnetic, alongside the bond order is also increasing. So here 15 electron to 14 electron, NO at 15 electron is paramagnetic, and NO positive at 14 electron it is diamagnetic. O2 is also paramagnetic, okay, remember it's 16 electron, O2 is paramagnetic. This is the electronic configuration which group is belong to. So last electron is going to 3p1, 3s2 3p1. That means we are talking about aluminum, and aluminum belong to 13th group and 3rd period, right? 3rd period and 13th group. Clear? Okay, which of the following pairs atomic number represents same group? So same group is 13 and 31. That is your periodic table questions. They're not much, like 1 or 2 questions will come, might or might not come. Okay, so we just focus on the questions that are going to come in our exam. Highest second ionization enthalpy. So second ionization enthalpy will be highest for the one in which we are removing the electron from either half-filled or full-filled orbital. If we are removing the electron from half-filled or full-filled orbital. Okay, so physics super easy. Okay, I am not able to read your comments because I want to finish this revision for you guys. Okay, see, chromium is there. Chromium has what? 3d5 4s1, 3d5 4s1. After removing this electron, the next electron is getting removed from the half-filled d orbital. That's why the second ionization enthalpy is the highest. Okay, remember this concept because from periodic table mostly ionization enthalpy concepts are being used. Ionization enthalpy is the energy required to remove the outermost electron. So it is endothermic. It is endothermic because we are giving that energy to remove that electron. So it is an endothermic process, and for endothermic process the sign convention is positive. For exothermic process the sign convention is negative. Next question. Electron gain enthalpy, again whenever you are moving along a period, what happens? Electron gain enthalpy increases. Electron gain enthalpy increases. So that's why when we are going from here to here, this is the same period, right? So electron gain enthalpy increases. Okay. Next question, as we move from left to right in the 3D series of elements, what happens when we go from 3D series here to here? What is happening here? The effective nuclear charge is increasing. Now as the effective nuclear charge is increasing, what is happening? The electropositive character is decreasing and the electronegative character is increasing. Okay, so when we go from here to here, they are very electropositive. They are able to donate electrons. But as we go alongside, what is happening? The electropositive character decreases and the electronegative character increases. Okay. Next one, density is given, mass of the solvent you have to calculate. Density is given, mass is also given. So we know mass is equals to what? This is molarity. This is molarity. Okay, mass will be density times volume. Density is equals to mass per unit volume, right? So density will be equal to, mass will be equal to density time volume. So mass comes out to be what? It comes out to be 1.25 times 1000, right? Volume is 1 liter. So we convert it into 1000 milliliter. Okay, now mass of solute is given to, what is the mass of solute? 3m. So normally we consider this as mole because we are considering that this 3m solution is present in this 3 molar solution is made in 1 liter of solution. Total solution is 1 liter. So that means this is your moles. Okay, now if you multiply the number of moles with the molecular mass of NaCl, you will find the mass of NaCl. Okay. Okay, mass of NaCl is there. This is the mass of solution. This is the mass of NaCl. In the solution, we have NaCl, water, right? We have NaCl and water. If we know the total mass of solution, we know the mass of NaCl. If we subtract the mass of NaCl, we'll find the mass of solvent, right? Which is water. Mass of water will be 107.5 gram. Okay. And one more thing, one really kind request. If you have some time, any one of you, please upload the physics paper so that it will help us analyze it fast for you guys. Okay. So if any one of you out there have the physics paper with you, please take a photo, quickly take maximum 2 minutes, click a photo and please upload it on the drive. Okay, the drive link is there in the chat section. Okay, please if you can do that. Okay, the next question. Number of atoms in 560 centimeter cube of oxygen at STP. So 5 centimeter cube of oxygen we are talking about. We know this much volume has this much atoms. This much volume of oxygen has this much atoms. Now in this one correction is there. This is the oxygen. This is oxygen molecule. So this is oxygen molecules. Okay. So when we talk about oxygen atoms, it will be half. It will be half. Why? Because oxygen molecule has 2 oxygen, right? So we will half it. So it is not this one. This will be 1 by 20. Slight correction is there. Okay. So 560 by 22,400 times this one by 2. So this will be 40. Okay, half. A 150 watt bulb emits this much light. So in this case, firstly you find the effective power that this bulb is giving. Effective power that this bulb is giving. Okay, what is that effective power? That will be 8% is emitted as light. So 8% of 150 watt is 12 watt, right? We know that. And number of photons emitted will be the power by energy. Power by the energy. How much is the energy in this case? So energy we calculated using like how many photons are there? 6600. We have wavelength, right? So energy is hc by lambda. Energy is h nu. Nu is c by lambda. Hc by lambda. Lambda is given to us 6600 angstrom. 1 angstrom is 10 raised to power minus 10 meter, right? So we just multiply it by that and we do the calculation. The answer will be 4 times 10 raised to power 90. Okay. Next question. An electron having spin quantum number this which it belongs to. So I don't know much, but I know if m is plus 3, that means L is also 3, because I know n is 1 to n, right? N is 1 to n. L is 0 to n minus 1, m is minus L to plus L including 0, and S is equals to plus minus half. Okay, S is equals to plus minus half. Okay. So if we see here, if m is minus L to plus L, 3, L is 3, that means if L is 3, that means the orbital involved is f orbital. The orbital involved is f orbital. Okay, next question, adiabatic change. Whenever you have an adiabatic change, what quantity is 0? The change in heat is 0, because there is no exchange of heat between the system and surrounding. If Q is 0, then according to first law of thermodynamics, change in internal energy is equals to heat plus work done. If Q is 0, that means delta Q is equals to, if Q is 0, that means delta U will be equal to what? Delta U will be equal to, delta U will be equal to W. Delta U will be equal to W. Q is 0 for an adiabatic change. Okay, ma'am didn't understand 11th question. 1 second. So in the 11th question, we are talking about, we are given density of solution density is given. This data we will use to calculate the mass of solution, right? Density is given, volume we know 1 liter, right? So we calculated using this the mass of solution, right? NaCl, 1 second, density is given to us 1.25. Using this data, we calculated the mass of solution. How? Mass is equals to density times volume. Mass is equals to density times volume. Okay, now we are given the molarity of NaCl solution. Molarity. Molarity means number of moles of NaCl present in 1 liter of solution, right? So these are the number of moles of NaCl. If we have the number of moles, can we calculate the mass of NaCl? Yes. Mass is equals to what? Number of moles times the molecular mass of NaCl. Now this is the mass of NaCl. This is the mass of solution. If we subtract the mass of NaCl from the mass of solution, we will get the mass of what? We will get the mass of the solvent. We are asked the mass of the solvent. Okay. The duration depends on when we'll finish the question. Okay. Physics was easy. Any one of you, Babu, I don't know who is there. Please, any one of you, can you upload the physics question paper for us? Okay. Same go do for the chemistry one. We'll share a link. Please upload it as soon as you can. Okay. Okay, for KCET, thank you, ma'am. Yes. Please, Babu, if you can, please upload the physics paper in this drive. The drive link is provided there. Some of you have phone, okay? So please do that. Okay. Yes, these questions are important for your revision. That's why we are doing it. This one we have done. Okay, adiabatic change we have done. Okay. Change in internal energy is being asked. Okay. temperature increases from 298 Kelvin when it absorbs heat. So absorbing means endothermic process, right? So that means heat is positive. Absorbing means endothermic, and for endothermic the sign is positive. Okay, we are asked the change in internal energy. This is the heat. Okay, how do you calculate the work done? There is constant volume. The thing is constant volume. If constant volume is there, that means the work done is 0. Why? Because work done is minus PdV. If volume change is 0, that means work done is 0. If work done is 0, then if you put in this expression, delta U equals to Q plus W, Q is plus 200 joules, okay, and work done is 0, that means change in internal energy will be 200 joules. Yes, thank you so much, Amshu. I'm sorry, I don't know what's your name. Amshu. Yes. Okay, next one. The pH is given. pH you have to calculate for the mixture. So whenever you're given a question like that, first of all, don't panic. You are given three things: H2SO4, HCl, and CaOH twice. These two are acids, this is base. Whenever acid base is there will be some neutralization will happen, right? So firstly, always calculate the number of milli equivalents. How do you calculate? Very simple. Whatever the volume of that solution is, let's say we are talking about H2SO4, this is 10 ml, right? Multiply that with its concentration. So 10 times 0.1 times the basicity, times the acidity or basicity. So in this case, H2SO4 gives 2H positive, right? So multiply that by 2, okay, because we are not getting 1H positive, we are getting 2H positive. So how many milli equivalents we have? 2 milli equivalents. Similarly for HCl, 5 ml of HCl, okay, it has a concentration of 0.2 m, okay. How many mole we get? How many H positive we get? What is the acidity? 1, right? So 1 milli equivalent. Similarly for basicity, for CaOH twice we will calculate in terms of basicity. 5 times 0.1, 5 times 0.1 times 2, because it is giving 2 OH negative. So now we see we have 3 milli equivalent of acid and 1 milli equivalent of base. 3 milli equivalent of acid and 1 milli equivalent of base. So neutralization, after neutralization we will be left with 2 milli equivalent of acid. We will be left with 2 milli equivalent of acid. Now how do you calculate the volume? How do you calculate the concentration? Because in the end we are asked the pH, right? So pH will be equal to concentration of H positive. What is the concentration? Whatever be the milli equivalent you have, you just divide them with volume. Whatever the milli equivalent you have, you divide them with volume. Total volume, in this case 10 plus 5 plus 5, that is 20 ml, okay. So that comes out 0.1 and pH will be 1 in this case. pH will be 1 in this case, okay. Yes, I can finish by 1 p.m. It's okay. I can finish by 1 p.m. So you guys have to come go inside at 1 p.m. again. Is it like that? Okay. Yes, the concepts will come in your exam. Okay. Next one, for this equilibrium, Kp and Kc relation. Firstly, the relationship between Kp and Kc is Kp equals to Kc RT raised to power delta Ng. Delta Ng is the number of gaseous molecule of product minus number of gaseous molecule of reactant. Okay, so if you subtract them, what will be the answer? So in this case, you have 2 gaseous molecule in the product side and 3 gaseous molecule in the reactant side. So delta Ng is minus. So if you put the minus value, Kp will be Kc by RT. Okay, let me just jump to some questions which I think are more important. Okay, 1 second. That is we have here, it is starting. Yeah, I think from here. Okay, now listen. Which of the following statement is not correct? The only one, this statement is not correct. Why? Because solubility of gas is directly proportional to pressure of the gas and inversely proportional to temperature of the gas. Okay, so if you increase the pressure, solubility will increase. If you decrease the temperature, solubility will also increase. Okay. This is your Henry's law. Okay, next question. When you try to dissolve a gas, mole fraction of water is asked. So we can calculate the mole fraction of gas, right? So 2 bar pressure, and this is the mole fraction. So listen carefully. So at 2 bar pressure, the mole fraction of that gas is 0.02. Again, Henry's law. Okay, if I double the pressure, in that case your mole fraction will also double. Mole fraction will be 0.04. Now this is the new mole fraction. We are asked the mole fraction of water. Mole fraction of water will be 1 minus this doubled quantity, 1 minus 0.04, that is 0.96. Remember, this is your Henry's law. Okay. Most of them were theoretical. Okay, so any one of you can tell me if any one of you has uploaded the physics question paper. Any one of you has uploaded the physics question paper? Bacha, can you tell me that? Yes or no? Just give me a thumbs up if you have uploaded it on the drive. Okay. The composition of an azeotropic mixture. So ethanol 95%, 5% water. Listen, when you have a positive deviation from Raoult's law, minimum boiling azeotrope will form. When you have a negative deviation from Raoult's law, maximum boiling azeotrope will form. Okay, for example, here you have ethanol and water, they form minimum boiling azeotropes. Maximum boiling azeotrope will be formed by nitric acid and water. Nitric acid and water. Okay, they will show maximum boiling azeotrope. Okay. Next question, a 5.25% and 1.5%. Then again, in this question, the isotonic word is used. Isotonic means both the osmotic pressures are same. Okay, if osmotic pressure is same, that means concentration are equal. In terms of concentration, we are given the data for two molarities. But see, the quantity of water is same. The solution are the amount of solution is same. So what we can do, we can ignore the solution part. We can just take the number of moles of the solute itself. We can take the number of moles of the solute itself. Yes. 1 second. No, we need it now actually. If you have some time, please, 2 minutes it will take. Any one of you has uploaded, I think. Please, any one of you if you have time. Ma'am, redox reaction balancing is the easiest one. Whatever option you are given, just put that value, and if it is coming equal, then use that value. Okay, that is the shortest trick for solving your redox reactions. Okay. Physics had theory questions more. Okay, that is surprising. Okay, now listen. So in this case, we'll equate the concentrations, right? So number of moles of both the components. So in this side we have a substance, and in this side we have urea. For urea, the molecular mass is 60. Again, 1.5 by 60, 5.25 by m, because this is percentage of solution, right? We can use that as mass only. Okay, if no data is given, you use that as mass only. Okay, the molar mass will be 210 gram. 210 gram. 1 second. Next question, in fuel cells we use platinum palladium as catalyst in this cell. So whenever you are doing these kind of questions, write this equation: E cell equals to E naught minus 0.059 n by n log of product upon reactant. Okay, very simple. One step you'll write it and then you'll know all your answers. See, zinc positive upon H2, H positive square. Whatever be the stoichiometry, it will go in the power. Okay, so if we increase the H positive concentration, what will happen? If we increase the H positive concentration, what will happen? In that case, this value will become negative. Negative become positive. So that means if we increase the H2SO4, the E cell will increase. Okay. And what about equilibrium? Again, if you increase this reactant concentration, the equilibrium will shift in the forward direction according to Lee-Catler principle, right? So equilibrium will go in the forward direction. So in this case, the equilibrium will shift to the right. Okay, forward direction. Okay. If we decrease the amount of product, equilibrium will go in the forward direction again. If we increase the amount of reactant, equilibrium will go in forward direction. It will make more product. If we decrease reactant concentration, equilibrium will go in backward direction to make more reactant. Okay. Next question, when simple aluminum, and in between these two you have to find out which will be anode and which will be cathode. Now listen, aluminum is more reactive. The one that is more reactive, that means it is getting oxidized. Remember this. More reactive means more willing to lose electrons. Lose electron means oxidize. It is getting oxidized, and whatever is getting oxidized, it become anode. Oxidized means anode. There is O anode and oxidized. Okay, and now that means copper will be cathode. E naught cell is E naught cathode minus E naught anode. So E naught cell is 2, E naught cathode minus E naught anode. Okay. Thank you, Amshu. Thank you so much. Okay. Now the answer will be minus 1.66 volt. Answer will be minus 1.66 volt. Tough. Do you need tough questions? Okay. Tough questions you need. So again, Faraday's second law. What is Faraday's second law? That weight deposited is directly proportional to the equivalent weight. For two components you have, right? We are talking about anode and cathode. The ratio, the weight deposited ratio will be directly proportional to the ratio of the equivalent weight. So in this case, the weight of silver deposited is given. The equivalent weight of silver we know. The equivalent weight of hydrogen we also know. Okay, the amount of hydrogen we can calculate, but the answer is given in volume. The answer is given in terms of volume. So 2 gram of hydrogen will give 22,400 centimeter cube. Okay, 0.01 gram will give 22,400 by 2 times 0.01. Now this 2 gram came from because hydrogen weight is 2 gram, right? H2 molecule weighs 2 gram. That's why it came. Okay, so the answer will be 112 centimeter cube. Don't do that, Anupma, don't do that. Okay, next question again, same you write the reaction. In this case we are asked if we increase in what condition the voltage will increase. So again, if you increase the concentration of Ag positive, if you increase this concentration, this term become negative. If this terms become negative, negative means positive. So increase in the concentration of Ag ions, increase in the concentration of Ag ion. This is Nernst equation. Remember this. Okay, to simplify it, use here 0.06. Okay, answer will come same, don't worry. Okay, next is conductivity of a saturated solution is given. So conductivity, we are given conductivity, we are given the molar conductance at infinite dilution. So firstly we'll calculate the solubility. So whenever you're given question like that, conductivity is given, molar conductance at infinite dilution is given, and you are asked solubility product. Okay, so solubility will always be conductivity divided by molar conductance at infinite dilution. That will be your solubility. If you know the solubility, what is solubility product of the concentration of products, right? S times S, that is S square. So that is your solubility product. Solubility product will always be S square, the square of the solubility. Square of the solubility. Okay. The mass of glucose that should be dissolved in 50 gram of water. What is the mass of glucose that should be dissolved as to produce the same lowering of vapor pressure? We know relative lowering of vapor pressure is directly proportional to mole fraction, right? Now see, the amount of water is same. That means the number of moles of water will be same. So we can just ignore that. We can only take the number of moles of solute. What is the solute? Glucose and urea. Glucose and urea. Okay. So see, the amount we don't know. The amount for glucose we don't know. Okay, but we know the molecular mass of glucose, that is 180 gram. Okay. For urea we don't know. For urea we know we have around how much? 1 gram of urea. Where is it? 1 gram of urea is dissolved in 1 gram of urea is dissolved in the same quantity of water. Okay, so the number of moles of urea will be 1 by 60. 1 by 60. So if you calculate it, the answer will be 3 gram. The answer will be 3 gram. Okay. Okay, next question. Which one of the following has highest freezing point? Now again, for these kind of questions we rely on Van 't Hoff factor. We are asked highest freezing point. Now think about it just for 1 second. Highest freezing point means what is high? -2 is high or -3 is high? -2 is high, right? In terms of freezing point, the maths is a little reverse, right? Because -2 is greater than -3. -2 is greater than -3. Okay, so highest freezing point means least depression freezing point, right? Because if depression freezing point has happened, it would have gone to -3. It would have gone to -3. So that means we are looking for what? We are looking for least depression in freezing point, and that will be for the least amount of solute. Least amount of solute means least Van 't Hoff factor, least value of I. So among these, this has the least value of I. This has the least value of I. Okay, so that will be your answer. Okay, next question, hypothetical reaction. Again, whenever you're talking about order of the reaction, look for the slowest step. Slowest step is this, right? So rate law will be written in terms of this, but we don't know A because A is an intermediate. Because see, this is the reaction A2 and B2. A2 and B2 is the reaction. So what will we do? We will do what? We will calculate the value of A using this first relation, that is equilibrium constant equals to rate concentration of the product divided by the concentration of reactant. So that is what? K, where is it? Yeah, A square by A2, right? So A we can calculate now. A will be KCA2 raised to power 1 by 2. We substituted the value here. Constant times constant will be some constant, but we are majorly focusing on the order. This, which is the sum of these powers that these concentration terms are raised to. Okay, so 1 by 2 plus 1, that will be 3 by 2. Okay. Half-life of a substance, first order kinetics is 5 minutes starting from 100 gram. Amount left. So amount left, firstly calculate how many half-lives are possible in 15 days. 3 half-lives are possible, right? In 15 days, 3 half-lives are possible. Okay, if 3 half-lives are possible, then the concentration of reactant that is left after n half-lives is equals to A0 by 2 raised to power n. A0 by 2 raised to power n. A0 is your initial concentration. Okay, n is the number of half-lives. So A0 is 100 by 2 raised to power 3. 2 raised to power 3, that will be 12.5 gram. Okay, this is the formula. You should remember it. Okay, if again this is the reverse of that formula. If this much substance is left after 240 minutes, then what will be the half-life? Now radioactive decay means first order reaction is there. Okay, so we started with 100%. After first half-life 50% will be there. After second half-life 25%, third half-life 12.5, fourth half-life 6.25. So that means in 240 minutes 4 half-lives are happening. 4 half-lives are happening. So that is your 60 minutes. That one half-life is 60 minutes. One half-life is of 60 minutes. Okay. Next question again, if both the quantities are equal, then you calculate the temperature. Okay, remember for the formula of the Arrhenius equation, which is K equals to A e raised to power minus EA by RT, or you can say ln of K equals to ln of A minus EA by RT, or you can say log of K equals to log of A minus 2EA by 2.303 RT. 2.303 RT. Okay, these are your formulas for Arrhenius equation. Yeah, time will be an issue, time management. First order reaction half-life is given. Again, the simple relation, 99% half, the time taken to complete 99.9% of any reaction is equals to 10 times the time taken to complete half of any reaction. So 10 times 45, 450 by 60, that will be 7.5. Why? Because we converted into from minutes to hours. Okay. Next question, again, this is a very lengthy question, but from this one, only one trick I can give you, that Van 't Hoff factor is very important. Second thing, how do you calculate Van 't Hoff factor in case of dissociation? What is happening here? Ionization. Dissociation is happening. If dissociation is happening, in that case, I is equals to 1 plus alpha into n minus 1. I is equals to 1 plus alpha into n minus 1. In case of association, the formula is 1 minus 1 by n into alpha. That is the formula for I. Remember it, these two formula. If you have ionization or dissociation, in that case, use this formula. I equals to 1 plus alpha into n minus 1. Okay, I equals to 1 plus alpha n into n minus 1. Okay, if you have association, in that case, use this formula, 1 minus 1 by n times alpha. That is the formula, simple. And since these are colligative properties, you can just directly add the elevation in boiling, depression, freezing point due to A, depression in freezing point due to B. You can just add them and calculate the value. This I is important. Please remember these formulas. For ionization or dissociation, this is 1 plus alpha into n minus 1, 1 plus alpha into n minus 1, and for association, it is 1 minus 1 by n times alpha. Now in this case, n is the number of associated molecules. Here n is the number of molecules after dissociation, Next question again. Outer orbital complex are those complex formed by weak filled ligand. Weak filled ligand form outer orbital complex. So here we calculated it 3D8. So only in this case outer orbital is possible. Why? Because even if we do pair, there are no 2d orbitals involved. Okay, because for 6 octahedral, the hybridization is d2sp3 or sp3d2. Okay, now see, if we have 8 electrons, even if we do pair it, we only have one orbital, one d orbital. Okay, so that will not make d2sp3. We need 2 d orbitals. Okay, nickel is there again. Let's solve some inorganic questions, organic chemistry questions first, then we'll go. No, let's finish these questions first. Okay, again, unpaired electrons, how many number of unpaired electrons it will have? It will have 2 unpaired electrons. Why did we say that? Because it is a paramagnetic complex. That means no pairing will happen. And if we have this configuration, if we have this 2 configuration, if paramagnetic complex is there, so that means the hybridization will be outer orbital complex. Okay, listen here. I'll just draw it somewhere. 1 second. 5, 6, 7, 8. Okay, so if we have a paramagnetic complex, that means these 2 electrons are not paired, right? So that means the orbitals that are involved are the next orbitals sp3, right? So the hybridization is sp3, and sp3 hybridization means tetrahedral. Okay, square planar have dsp2 hybridization. Next question. Again, MABCD have 3 geometrical isomers, no optical. Why? Because in case of planar molecules, you don't have any optical isomerism, because they have a plane of symmetry. Okay, so one more thing. Wavelength. Remember, in this case, whenever we are going from a weak filled ligand to strong filled ligand, the crystal field splitting energy increases. If energy increases, then wavelength decreases, because energy and wavelength are inversely related. If energy increases, the wavelength decreases. Okay, if wavelength decreases means, this is the sequence we are asked, right? Decreasing order of wavelength. So this will have the highest wavelength, medium, and the lowest wavelength. Okay, now when we are depicting the color, remember this color wheel. So whatever color is given to you, V, B, G, Y, O, R. If any complex absorbs violet color, it will reflect yellow color. It will show yellow color. If it absorbs blue color, it will show orange color. If it absorbs green color, it will show red color. Okay, this is the complementary color wheel. One more thing you might need when you're going from VibGyor, here to here, what is happening? Wavelength is increasing. Wavelength is increasing. It is around 400 and this is around 700 nanometer. Below that you will have UV light. Below that you have UV light. UV light is non-visible. It is not visible at all. This is the visible spectrum. VibGyor 400 to 700 nanometer. Wavelength increases. That means the energy decreases. That means the energy decreases. One more thing. Iron Fe2 positive has green color. Fe2 positive has green color. Manganese 2 positive has pink color. Manganese ion has pink color. Copper 2 positive has blue color. Copper 2 positive has blue color. And then you have vanadium 4 positive. Vanadium 4 positive also have blue color. Vanadium 4 positive also have blue color. Okay, remember these three are important. Okay. Next question. Again, what is wrong with this one? So in this case, this is an inner orbital complex, not an outer orbital complex. This is an inner orbital complex because in this case the configuration is 3d3. 3d3 means already two orbitals are empty, or already two orbitals are empty. This is paramagnetic because without pairing we are doing nothing. We are doing it already have two empty d orbital. In place of two empty d orbitals means outer orbital complex will form. No, so inner orbital complex will form, not outer orbital complex. Okay, next question. Which of the following system has maximum number of unpaired electron? D7 high spin. High spin, low spin, you should understand. High spin means that the next electron, if we have like this, the next electron is going to here, is going in EG, that is high spin. If we have low spin, that means the electron is staying in T2G only. That means the electron is staying in T2G only. That is low spin and that is high spin. Okay, next question. Crystal field splitting energy is this much. So there is a relation between crystal field splitting energy for tetrahedral complexes and octahedral complexes. So crystal field splitting energy for tetrahedral is 4/9 of crystal field splitting energy for octahedral complexes. Remember this, tetrahedral is 4/9 of octahedral complexes. Okay, so 4/9 of 18,000, that will give 8,000. Again, MnO2, whenever MnO2 manganese oxide is fused with KOH in O2, we get manganate. MnO4 2 negative is manganate. MnO4 2 negative is manganate. MnO4 negative is permanganate. Okay, this is permanganate. MnO4 2 negative is this is MnO4 2 negative. This is manganate. And MnO4 negative is permanganate. This is permanganate. Okay, so remember the name. Manganate is this MnO4 2 negative. MnO4 2 negative and it is green colored. MnO4 2 negative and it is green colored. Okay. Okay. Again, color wheel we have explained. Which of the following has same color? Fe2 positive, as I told you, it is green color. Fe2 positive is green color. Copper 2 positive is blue color. Not same color. V4 positive and copper 4 positive, copper 2 positive, both are blue color. So they have same color. Again, iron is green color. Manganese is pink color. Mn2 positive is pink color. Okay. Yes. All of these are repeated questions. I don't know. Okay, next question. Ammonium dichromate. This is ammonium dichromate. When it dissociates, we get a green colored compound, that is chromic oxide, Cr2O3. Cr2O3. This one question you might get confused. Number of moles of K2Cr2 that are reduced by 1 mole of Sn2 positive. So this is getting reduced, this is getting oxidized. This gets oxidized to Sn4 positive. That means how many electrons are involved? 2 electrons are involved. 2 electrons are involved. Now remember, whatever be the amount of species that is getting reduced should be equal to the amount of species that is getting oxidized, right? That's how you balance a reaction. Amount of species that is getting reduced should be equal to the amount of species that is getting oxidized. Okay. So in this case, when you reduce Cr2O7 2 negative, it reduces to Cr3 positive. That is +6 to +3. +6 to +3. Okay, that means 3 electrons are involved, right? But we have 2 Cr. 2 Cr is there, that means 6 electrons. That means 6 electrons. Okay, so what you will do? You will do nothing. Moles of K2Cr2O7 times N1. N1 is the number of electrons involved. Number of electrons required for reduction, okay, equals to moles of Sn2 positive times N2. N2 is the number of electrons involved in case of oxidation. Number of electrons involved in case of oxidation. We don't know this amount. We know this because we are given 1 mole of Sn2 positive. You just follow this relation all the time. Okay, follow this. Calculate the number of electrons. One time you will be given oxalate, ferrous oxalate. We are given ferrous oxalate, Fe2C2O4, I think, C2O4, yeah, Fe2C2, no, ferrous oxalate. Ferrous oxalate, in case of ferrous oxalate, you will get 3 electrons. You will get 3 electrons, one from Fe2 positive, one from Fe2 positive and 2 electrons from here, 2 electrons from here. So 3 electrons are involved. Remember the number of electron contribution, that is very important. And then use this formula, moles of that reducing species times the number of electrons required for reduction should be equal to moles of the oxidizing species times the number of electrons involved for oxidation. Okay, so here we did not know this amount, one amount will be unknown, rest all the data will be known to you, x will be equals to 1 by 3. Next question, amphoteric oxide. So remember for this one, whenever you have low oxidation state, we will get basic oxides. Low oxidation state means what? Plus 2 plus 3 plus 2 plus 3, these are your low oxidation state. If you have medium oxidation state, plus 3 plus 4, sorry, plus 4 plus 5 plus 6 types, plus 4 plus 5 plus 6, these are your medium oxidation state, that will be your amphoteric oxide. And if you have high oxidation state, plus 6, you can ignore this plus 6 here actually, you can ignore this one, plus 6 won't be here. Okay, so plus 4 plus 5 and plus 6 plus 7 are your high oxidation state. Plus 2 plus 3 low oxidation state, basic oxide, plus 4 plus 5 high oxidation, medium oxidation state, amphoteric oxides, plus 6 plus 7 is your high oxidation state, acidic oxides. Okay, so here only in this case we have plus 5 and plus 3, plus 5 and plus 3, which is your amphoteric oxide, plus 4 and plus 3, yes. Okay, so just remember this one is important, okay. Next question, experiment, what would be the pH? When we are talking about pH, we focus on H positive or OH negative. We only focus on H positive and OH negative. Okay, so what will happen at cathode, we have H positive and Na positive. Now since H positive has lower discharge potential, in case of aqueous NaCl at cathode we will get H2. In case of aqueous NaCl, in case of aqueous NaCl at cathode we will get H2. Okay, so what is the reaction? This is the reaction. 2H2O adds 2 electrons, we get 2 OH negative. Okay, so 2 mole of electrons is producing 2 mole of OH negative. 2 mole of electron is producing 2 mole of OH negative. Okay, so how many mole of electrons we have? We have 0.04 Faraday, right? 1 mole of electron equals to 1 Faraday. 1 mole of electrons equals to 1 Faraday. So 2 mole of electron, 1 second, 1 mole of electrons equals to 1 Faraday. We have 0.04 Faraday. Okay, so that means 0.04 Faraday will give how much? 2 by 2 times 0.04. That will be 0.04. That will be 0.1. 0.04. Okay, 1 second. I don't know why. Listen, 2 mole of electrons gives 2 OH negative. That means 2 Faraday gives 2 OH negative. We have how much Faraday? 0.04 Faraday. 0.04 Faraday will give 0.04 mole of OH negative, right? Now we need to calculate the concentration. How do we calculate concentration? Number of moles per unit volume. This is the number of moles, 0.04. Volume is 400 ml. Volume is 400 ml. So 0.4. That will be 0.1. We calculate POH. POH is negative logarithm of OH negative. What is the relation between pH and POH? pH is 14 minus POH. 14 minus POH. Okay. Next one is the mass of ethanol that should be added to 2 liter of water so that the solution freezes at -2. Then again, how much is the amount we should add? That is molality. You calculate using molality. Molality is the number of moles of solute present in 1 kilogram of solvent. 1 kilogram of solvent. Okay, so 2 liter of water, we can just take 2 kilogram. We can just take 2 kilogram. Okay, and the solution new freezing point is -2. So initially it was 0 minus -2. Okay, whenever we talk about del TF is nothing but TF of the pure solvent minus freezing point of the solution. Pure solvent minus solution. Okay, similarly when we talk about del TB, boiling point, elevation in boiling point, that means the boiling point of the solution minus the boiling point of the pure solvent. Okay, that is there. Relative lowering of vapor pressure is nothing. Relative lowering of vapor pressure is pressure of the solvent, pure solvent, minus pressure of the solution divided by the pressure of the pure solvent. Okay, these 3 things you should remember. Next thing, again, we are asked to calculate the molar mass. Molar mass is being asked. So again, see, concentration is there. In concentration terms, we use molarity. Molarity is the number of moles of solute present in 1 liter of the solution. Okay, so we have number of moles which is 1.26 by m. We just need to calculate this m. All the data is given to us. All the data is given to us. Okay, next question. Equimolar NaCl and BaCl2, same freezing point. The freezing point of NaCl is -2. So you see, the freezing point, depression freezing point is directly proportional to Van 't Hoff factor. So for BaCl2 and NaCl, if you take the ratio, BaCl2 the Van 't Hoff factor is what? 3, and for NaCl the Van 't Hoff factor is what? 2. And we know this depression freezing point for NaCl is -2. The depression freezing point for NaCl is -2. So we just take the ratio and equate it. We get our answer which is -3. Okay, sometimes you don't need to use the entire formula. You just need to use that ratio relation, that ratio relationship. Okay. Okay, next question again. I, you have to calculate delta TF is equals to I KFM. KF is given to you, molality data is also given to you, delta TBF is also given to you. You just calculate it. This is the relation when you have, see, I, we will use I only in two cases, whenever you have association or you have dissociation. Okay, whenever you have association or dissociation word written in your question specifically, unless or otherwise you do not use it. Okay, you simply use it, del TF equals to KFM, KFM. Okay. Next question, we have aluminum displaces hydrogen from dilute HCl. Aluminum displaces hydrogen but silver does not. That means aluminum is more reactive. As I told you, the species that is more reactive will be oxidizing. That means it will be anode. Okay, what will be cathode? Silver will be cathode, and E naught cell is E naught cathode minus E naught anode. E naught cell is E naught cathode minus E naught anode. Okay, again pH is being asked. We know this is the relationship. This is the reaction that is happening. This is the reaction. H positive adds 1 electron, we get half H2. E naught reduction. E reduction will be E naught reduction minus 0.059 by 0.06 you can do by 1 n. This is n, number of electrons is 1, log of H2. H2 pressure is 1 atm. If not given, take the pressure as 1 atmospheric. Okay, divided by H positive, right? This is pH. Negative logarithm of H positive will be pH, right? So we just put all the values and do the calculation. Always check your calculation twice. Okay, whenever you are doing it, don't take a shortcut. Check your calculation once, because see, you will be have closely spaced answer. See, this is the correct answer, but this is also given to us. Okay, so in that case, please check your calculations. Yes, we are going there also. Equivalent weight. So again, weight deposited is equals to ZIT. Z is electrochemical equivalent, I is the current, T is the time, normally in seconds. Z electrochemical equivalent is equals to what? Equivalent weight by Faraday. Equivalent weight by Faraday. This is the relationship. Okay, so we just substitute this value here, equivalent weight by Faraday, and we'll calculate the equivalent weight. That will be 7.72. Next question. Electro-potential. Again, the metal most reactive will be the one which is oxidizing, right? So that means it should have high oxidation potential, or low reduction potential, you can say. This is reduction potential. So least reduction potential is for this one, minus 0.76. Least reduction potential. This will be the most reactive. Let me see where we find. Again, for a spontaneous reaction, E naught cell should always be positive and delta G naught should always be negative. Let me check if we have the questions here. This one. Okay, this question, in this question, endothermic and exothermic. Listen, these are the graphs for endothermic and exothermic reactions. Endothermic and exothermic. This is for endothermic and this is for exothermic. Okay, so exothermic means the product is releasing energy. The energy is getting released. The product will have lesser energy than your reactant. The product will have lesser energy than your reactant. Okay, so in this case, the activation energy for reactant is less and the activation energy for product is more. What do you mean by activation energy? It is the minimum energy that reactant should have to cross the to convert into product. Similarly, this is the activation energy that the product should have to convert into reactant for the reverse reaction. Okay, this is for exothermic. Now this for endothermic, reactant here and product here. So as you can see, this energy is less, this energy is less. This is the activation energy for backward reaction, this is the activation energy for forward reaction. Okay, so this is less. So in this case, the answer is the activation energy for forward reaction is more than that for the backward reaction. Okay. Complex ion relationships, again this is +3, this is +2. Okay, in this case you have 5 electrons, in this case you have 6 electrons. Even if you pair them, even if you pair these 5 electrons, one will be unpaired, so that means it will be paramagnetic. I'll look for the organic questions. Where are those? Organic. Okay, here. Okay. When upon the reductive reaction with alkaline cheminophore, which one of the following is not converted to benzoic acid? 1 second. So which one of the following will not be converted to benzoic acid? This one, because it does not have any benzylic hydrogen. There is no benzylic hydrogen. For getting converted to benzoic acid, you need one benzylic hydrogen. Okay, yes. Next question. Propanoic acid, HVG. HVG means you need an alpha hydrogen. Firstly, this reaction is given by acids, carboxylic acid. Second condition is they should have an alpha hydrogen. What is the alpha hydrogen? This is the alpha hydrogen, right? The carbon that is connected to this carboxylic acid, it should have a hydrogen. And this hydrogen gets substituted. In place of this hydrogen, a bromine, a chlorine, any halogen will come. That is your HVZ reaction. Okay, so we get propanoic acid and we get chloropropanoic acid. Chloropropanoic acid. Okay, so which is more stronger? propanoic acid is more strong, chloropropanoic acid is more stronger, right? Whenever you have an electron withdrawing group, they increase acidity, they increase the acidity, they decrease the basicity, okay. And whenever you have an electron donating group, they increase the basicity and decrease the acidity, okay. Acidity, basicity, you should look in the context that acid means electrons are being, acid accepts electron, bases donate electrons, okay. Again, this reaction is what? Friedel-Crafts reaction, right? Friedel-Crafts alkylation. So this will get substituted here. We will get isopropyl benzyl. X will be isopropyl benzyl. Then you do oxidation of that. You will get cumene peroxide, cumene hydroperoxide. After that, you do hydrolysis. You will get phenol plus acetone. This is the compound. If you do hydrolysis, you will get phenol here, and this will be the other compound, CH3COCH3. That is your acetone. Okay. One more thing. I don't want to leave you, so I'll do the name reactions also. If you can just stay. Reaction of the propanol with methyl, this is Grignard reagent, okay. So Grignard reagent, whenever Grignard reagent is reacted with any carbonyl compound, don't do anything, form a OH on one side, whatever be the methyl, attach it on the other side. Form a OH, this oxygen will convert into OH, and whatever methyl group is there, just whatever alkyl group is there, just attach it to the carbonyl carbon, that is your answer, okay. Dehydration means you are getting carbocation. Dehydration means carbocation is getting formed, and the more stable the carbocation is, the reaction more fastly that reaction will happen, okay. So in this case, as you see, this is a tertiary carbocation, where this is a tertiary carbocation, this is most stable, okay, and this is primary, so this will be the least reactive towards dehydration. Among these two, you have two choices, this and this. So this is purely secondary, this is secondary, but you can transfer one hydrogen from here, and then it will become a carbocation. This is a tertiary carbocation, so it has a chance of rearrangement. So that means in that case, this is more stable, this is more reactive towards dehydration, okay. An aromatic compound with molecular formula orange. So this should be what is that compound? You see, these three compounds are similar. In your answers also, you'll find that choice. Three compounds are similar. That means these are not the answer. This is the answer. Why? Because in this case, we are getting carboxylic acid. Firstly, this has benzylic carbon. This has benzylic hydrogen. This benzylic hydrogen will convert into carboxylic acid. Here, no benzylic hydrogen. Okay. Next question. How do you calculate the number of unpaired electrons? So the magnetic moment is equals to square root of n into n plus 2, okay. So we just calculated the number of, that is 3 unpaired electrons. 3 unpaired electrons means the that is the answer, 3 unpaired electrons. Okay, 1 second, just give me 1 second. Okay. So when nitro compounds, electron withdrawing group, whenever you treat electron withdrawing group, they are meta-directing. Electron donating group are ortho and para-directing. I'll give you the basic example. So you have COH, you have CO, you have NO2, you have X, not X actually, NO2. These three compounds are there. Whenever you see these group attached to the ring, what will happen? Meta-directing. The product will be meta-directing, okay. And if you have OH, if you have halogen, if you have OCH3, okay, or what else we have, NH2, if you have, these are your electron donating group. Electron donating group means product will be ortho and para-directing. In this case, the product is meta-directing. Again, so nitro compound is there, meta product will form, we get a meta product. Now after this is reduction. Tin in concentrated HCl is reduction, okay. So if you reduce it, reduces to aniline. After that, this is diazotization, nitrous acid, we'll get N2Cl, and we have water here. Water in that case, this is very reactive. This diazonium salt is very reactive. It will get converted into OH, okay. Increasing order of basic strength, nitrobromo-toluidine. Again, basic strength, we are looking for basic strength. These are electron withdrawing group. This is electron withdrawing group. This is also electron withdrawing, and this is donating. So the order should be 1, 2, 3. Okay. One more thing. A non-essential amino acid proline, because we have that sequence PVT, TIM, A, HIL. Lysine, leucine, HIL is histidine, A is arginine, methionine, tryptophan and threonine, and I is isoleucine, valine and phenylalanine. Okay, wrong statement is, yes, it has a cyclic ester. Yes, the wrong statement was glucose has cyclic acetal with its CHO group. It does not form acetal, it forms hemiacetal. It forms hemiacetal. 1 second. Conjugate base, that is not important. Some questions were up, I think. 1 minute, give me just 1 minute. Markovnikov rule, following reaction. Okay. When 2-bromopentene is treated with alcoholic solution of potassium hydroxide, with major product will be. So you see, potassium hydroxide is there. So in this case, we are doing elimination. Whenever you have elimination, you use Sedzeff rule. What is that Sedzeff rule? That the more substituted alkene will be the major product. More substituted means the alkene that have more alkyl group attached to it. So in this case, we have two possibilities. We can either remove the electron from this carbon or this carbon. We can either remove the hydrogen from this carbon or this carbon. So in this case, if we remove from here, we will get a more substituted alkene. That's why this is your major product, pentoene. Which of the following chemicals is non-aromatic? So non-aromatic means they are non-cyclic, non-planar, non-conjugated. They have a sp3 carbon in between two sp2 carbon. Okay, what is aromatic? Aromatic are cyclic, planar. Cyclic, they are planar, they have conjugation, they follow Huckel rule. What is Huckel rule? 4n plus 2 pi electron rule. Okay, so which among the following is non-aromatic? This is because it has a sp3 carbon in between two sp2 hybridized carbons. Okay, next is hydration, right? Product P will give what? Will get what? Product P, CH3CHO, right? We get an aldehyde. Aldehyde gives Tollens test. Aldehyde gives iodoform test, CH3CHO. For iodoform test, the condition is CH3CO or CH3CHOH group. CH3CHOH group. Then Brady's reagent is 2,4-DNP. Again, this test is also given by carbonyl compounds. Okay, and Victor-Mayer test is one test that is given by alcohols. That is given by alcohols only. Primary alcohols turns red color, secondary turns blue, tertiary turns colorless. Tertiary turns colorless. Okay, the organic compound during the formation of peroxide. If peroxide is there, anti-Markovnikov rule, that means the bromine will attach to the bromine or any nucleophile we are given, that will attach to the less substituted carbon. So in this case, the product will attach here, HCH3CH2Br. Okay, now give me just, okay, Markovnikov rule, do this question, give me just 1 minute. Okay, if some of you are there, I want to do the name reaction also. Okay. Yes, not 1 hour. I'll try to wrap it up before 2 so that you can go and have revise and all. Okay, let me just check once. Where is that? Just 2 minutes, guys. I'm just checking it. Okay, I think we can open here. Just a moment. Yes. Important name reactions, we should not leave them actually. Okay. Aldol condensation given by aldol condensation is a reaction given by carbonyl compound that have alpha hydrogen. Product formation very easy. You do one thing. You have O in this side and the other carbon. Let's say this has this alpha hydrogen, CHO, like this it is there, right? So remove a water molecule like this, and then connect them with a double bond CHO. This is alpha beta, unsaturated carbonyl compound. The product will be alpha beta unsaturated carbonyl compound. Okay, so carbonyl compound, alpha beta unsaturated. Okay, you can even draw it with your imagination, but if you don't, then arrange it like this, one here and other here. Both should have both should have alpha hydrogens. Okay, if one does not have alpha hydrogen, in that case you already know only one product is possible. Okay, that is your product for that is your aldol condensation. Okay. Next is carbylamine reaction. So in carbylamine reaction, maybe the byproduct is wrong or something, I don't know. Okay, but I do know that carbylamine reaction is given by primary amines. Only primary amines give this reaction. When you treat primary amines with chloroform in presence of KOH, you will get NC, RNC, isocyanide compound. These are foul smelling compound. This is also an important test that is used to distinguish between primary, secondary and tertiary amine, as this reaction is only given by primary amines. Okay. Next is Cannizzaro reaction given by compounds, carbonyl compounds that have no alpha hydrogens. We get two products. One is a carboxylic acid and the other is an alcohol. Carboxylic acid and alcohol. So compounds that do not have any alpha hydrogen, when you treat them with concentrated base, any base you treat them, what happens? In that case you get two products, a carboxylic acid and salt, and carboxylic acid and alcohol, Okay, whatever is there, you just make a carboxylic acid and alcohol out of it. Okay, next is Clemmensen reduction, important reaction. All the carbonyl compounds, aldehyde ketones, they get converted into alkanes. Aldehyde or ketone get converted into alkanes. That is your Clemmensen reduction. Okay, what reagent you use, that is important. Zinc amalgam and HCl. That is a reagent that we use in case of Clemmensen reduction. Similar, we have Wolff-Kishner. The reagent is different but the product is same. We will get what? We will, from aldehyde or ketone, we will get alkyl group. We will get alkanes. Aldehyde and ketone get converted into alkanes. Okay. ETARD reaction, we use this reaction to produce benzaldehyde. So whenever you have a toluene, okay, whenever you have toluene, you treat it with chromial chloride. You treat it with chromial chloride in presence of CCl4. In presence of CCl4, we get aldehyde. Okay, so toluene gets converted into benzaldehyde. Okay, clear? ETARD reaction, Finkelstein, is a halogen exchange reaction. So we synthesize iodoalkanes. Whenever you have a chlorobromoalkane, we treat it with sodium iodide in acetone. In acetone, what will happen? We get iodoalkane. So it's just a halogen exchange. It's a haloalkane getting converted into a haloalkane. Just the haloalkane is different. We get iodoalkanes. Okay. Friedel-Crafts alkylation, again Friedel-Crafts alkylation and acylation. So in this case you have alkyl group, R group will substitute on the ring, or in acylation you have this RCO group that will substitute on the ring. Okay, in this case R group, and in other case you get RCO group. Okay, that means if we have, let's say we have CH3CO, Cl, and we treat it in presence of FeCl3 or AlCl3, what will happen? In that case COCH3 group will attach here. Okay, if you have RX, the R group will attach here. Okay, that is your Friedel-Crafts alkylation alongside acylation. Gabriel thalamide, it is used for synthesis of primary aliphatic amines. Okay, not for aromatic, only for primary aliphatic amines. Okay. Simple. You have a thalamide, you treat it with potassium hydroxide. Okay, you get this salt. This salt, when treated with any alkyl halide, this R group is important because this will be the amine that we will be getting. Okay, we'll get N-alkyl thalamide. Then again we treat it with any, it undergo hydrolysis, and we will get our primary amine. This is Gabriel thalamide synthesis. This is thalamide. Okay, it looks scary, but it's very easy. You just synthesize. It depends directly on the alkyl halide that we have taken. If this alkyl halide, whatever alkyl halide we have taken, same amine we will get. Gattermann reaction, again Gattermann reaction is used to synthesize your aryl halides. Okay, so very easy. You take copper. So whenever you have a disonium salt is treated with, how do you synthesize disonium salt? Whenever you have aniline, when you treat aniline with the nitrous acid, which is NaNO2 in HCl at around 0 to 5 degrees Celsius, okay, what will happen? It gets converted into disonium salt. This is very reactive. Disonium salt, when treated with copper and HCl, copper, metal and HCl and halo acid. Similarly, copper, metal and HBr, then we will get bromobenzene. Okay, so this is Gattermann reaction. Similar, we have one more reaction, Sandmeyer reaction. Same product we will get, but the reagent is different. In that case, instead of using copper metal, we use salt of copper metal, CuCl2 in HCl, CuBr2 in HBr. We will do that also. Okay, that is your Sandmeyer reaction. This is your Sandmeyer reaction. Okay. Sandmeyer reaction. Next is your Gattermann-Koch reaction. Gattermann-Koch reaction is a different reaction. Gattermann reaction we synthesize from disonium salt. What do we get? We get aryl halides. We get aryl halides. But here we get benzaldehyde. Here we get benzaldehyde. Gattermann-Koch. Koch should be used, remembered as it gives benzaldehyde. Okay. Whenever you have CO, okay, remember this. Whenever you have this CO group, CO mostly convert into aldehydes. CO group mostly convert into carbonyl compound, as in you get aldehydes or you get ketones. Okay. But if you have CO2, then directly you will get carboxylic acid. 90% of the time, if you have CO2 there in the reagent thing, it will get converted into carboxylic acid. Remember that. Okay. Now Gattermann-Koch, very easy. Benzene treated with CO in HCl, in presence of AlCl3 and CuCl, we get benzaldehyde. Okay. So benzene when treated with CO and HCl. CO and HCl, remember this reagent, CO, HCl and AlCl3. These are Gattermann-Koch reaction. Okay. So when you treat it, we get benzaldehyde. ETAD reaction was also there. Chromial chloride in CCl4. Chromial chloride in CCl4. Okay. Riemer-Diemer reaction. Riemer-Diemer reaction is very easy. So Riemer-Diemer reaction means whenever you have a phenol, if you treat it with chloroformine NaOH, we get ortho-hydroxybenzaldehyde or para-hydroxybenzaldehyde. So phenol gives this reaction to get converted into ortho and para-substituted benzaldehydes. Ortho and para-substituted benzaldehydes. Okay. Yeah, no time. I know, almost done. Rosenman reduction. Again, Rosenman reduction is a reduction reaction. Remember, this is a reagent, H2PdBSO4. So any acyl chloride you have, if you reduce them with H2PdBSO4, they get converted into aldehyde. Acyl chloride will get converted into aldehyde. This is the reagent, H2PdBSO4. So Rosenman reduction means this acyl acid chloride will get converted into aldehyde. Okay, that is your Rosenman reduction. Okay. Sandmeyer reaction, again same reaction, disonium salt when treated with copper salt in HCl, let's say CuX in HX. Copper salt in presence of halo acids, we will get that aryl halides. Okay, simple reaction, same reaction, similar to your Gattermann reaction. Stephen reaction again, nitrile compound, any nitrile compound you have, they get converted into aldehydes. Conversion of nitrile compounds into aldehydes using this reagent SnCl2 in HCl, SnCl2 in HCl. That is your reagent. Nitrile compound gets converted into aldehyde. That is your Stephen reaction. Okay. Next is Schwarz reaction. Again, halogen exchange reaction. We used Finkelstein for iodoalkanes. This we used for fluoroalkanes. AgF, COF2 also there. Okay. AgF, HgF. Okay. AgF, HgF, COF2. Okay. These 3-4 reagents are there that you should remember when you're dealing with Schwarz reaction. Okay, this is Schwarz reaction. Again, halogen exchange reaction. We get fluoroalkanes from this one. Schwarz reaction reagent, you know, AgF, HgF, COF2. Then we have Williamson ether synthesis. We synthesize ether. We have an alkoxide ion and we have a alkyl halide. So normally this reaction goes by SN2 pathway. Only when this alkyl halide is primary or secondary. If this alkyl halide is tertiary, then in that case a different reaction will happen. We will not get ether, we will get alkene. In that case, if tertiary is there, we will get alkene. Okay. Primary and secondary SN2 reaction, we will get an ether, ROR, that is an ether. Okay. Next is Wolff-Kishner reaction. Again, we have hydrazine here, and KOH, ROH, KOH in ethylene glycol, that is the reagent. Hydrazine plus KOH in ROH. Yes, bye everyone. Ma'am, last please tell us some logical tukka strategy. Tukka you looking for, don't do that. Tukka strategy. Mostly in case of calculation questions, you can go for the most common answer. Look for sometimes you will be given digits like that, right? 4 is to 10 is to power minus 4, 4 is to 10 is to power minus 5, 3 is to 10 is to power minus 8, 6, and 5 is to 10 is to power minus 4. So look for the number that is common here, which is 4, like this. Calculation may sometimes, it won't work every time, sometimes it may work. Okay, so 4 looks common here, and similarly here also 4 is common. So the answer should be this one. It's like this. Sometimes you can use them, sometimes you cannot use them. Okay. Please let me complete this one, then we'll talk. Okay, few reactions are there. Wolff-Kishner, again, we convert your aldehydes and carbonyl compounds, whatever, aldehydes or ketones to alkanes, okay, that is your Wolff-Kishner reaction. Okay, next one is Wurtz reaction. Wurtz and Wurtz-Fittig are two type of reaction. In both the reactions we get an alkane type of thing. In this case we get alkane, in that case we'll get a substituted alkane substituted, alkyl substituted arene. Okay, we get alkyl substituted arene. So Wood's reaction, when you treat any alkyl halide with sodium in dry ether, we get alkane, symmetrical alkane we'll get. Okay, that is your Wood's reaction. Okay, now Wood's fitting is different. In this case, you have any aryl halide and you treat it with alkyl halide, aryl halide with alkyl halide, aryl halide with alkyl halide, and you will get a substituted aromatic compound, Okay, next one is HVZ, again given by carboxylic acid that have alpha hydrogens. So in this case, the alpha hydrogen here, right? So this hydrogen will get substituted with bromine. In this case, Br2 PbR3. Okay, we normally use Br2 in red phosphorus or something. That is your HVZ reaction. Okay, so this will get substituted. Okay, alpha halo acid. The compound is alpha halo acids. Okay, Hoffman-Romamide degradation, very important reaction. Whenever you have a 1 degree amide, primary amine you are given, primary amide. So in this case, this group you can eliminate and you get a primary amine, whatever. So the amide that you have taken, your amine will always be 1 carbon lesser than that amine. That amine will be 1 carbon lesser than that amide. Okay, sorry for the mispronunciation sometimes. Okay, what is the reagent we use? Chlorine in base. So anywhere, chlorine gas, bromine gas in basic medium, right? And hydrolysis. Kolbe reaction. So firstly, we have a phenol, we convert it into phenoxide ion. And then again I told you CO2 is there. In this case, we use CO2 at 400 Kelvin, around 4 to 7 atmospheric. CO2 at 400 Kelvin, around 4 to 7 atmospheric pressure. We get ortho substituted carboxylic acid. At ortho position, carboxylic acid will form. At ortho position, we will get carboxylic acid. Okay, this OH will remain as it is. So we get salicylic acid. This is salicylic acid. Okay, this is salicylic acid. What I am telling wrong, bro? Yes, the voice is high actually. I don't know if I can. What did I tell wrong? Tell me please. What did I tell wrong to you? Hello. Ma'am, name at last once, write all the reagents used in name reaction, please, it will be helpful. Biomolecule question, huh? Okay. Haloform reaction, again haloform test is given by compound that has CH3CO or CH3CHOH group. Okay, in that case we get this yellow PPT we get this haloform. Sometimes it's yellow depending on the iodoform color is yellow PPT, right? So normally iodine we use for iodoform test. Okay, and the compound we get is sodium carboxylate. That's a carboxylic sodium salt of carboxylic acid. Hinsberg test is also done to differentiate between primary, secondary and tertiary amines. When we treat them with sulfonyl chloride, this is the reagent. Benzene sulfonyl chloride is the reagent. So if we treat it with primary amines, we get this compound, right? And if we add alkali to this, it will be soluble in alkali. That means it is primary alkyl halide. If it is not insoluble, that means it is secondary. And in terms of tertiary, they will not even react in the first step. Okay, so in this case we get clear solution. In this case we get white precipitate, and in this case unreacted layer will be there. No reaction will happen. Markovnikov rule, again whenever you are given two possibilities. So in Markovnikov rule, this HX is there, right? When you have peroxide, no peroxide, and if you have peroxide, if peroxide is there, anti-Markovnikov rule is used, and if peroxide is not there, we use Markovnikov rule. Okay, so according to Markovnikov rule, what happens, the halide ion will attach to the more substituted carbon, and in this case the halide ion will attach to the less substituted carbon. Simple. This is more substituted carbon, this is less substituted carbon, less, and this is more. Okay, so in this case, as you have seen, the halide ion will attach to the more substituted carbon. Okay, and when you have peroxide present, you use anti-Markovnikov rule. In that case, your halide will attach to the more substituted carbon, less substituted carbon. Okay, Stitzef rule again used when we are doing elimination. So in case of elimination, the major product will always be the product which will always be the more substituted alkene. The alkene, in that case, the alkene which has more number of alkyl group attached to it. Okay, I think that was it. Okay, one more thing, biomolecule questions. Do we have some biomolecule questions? Let me just check once. I can just revise you guys one more question. So as in, why do we use, what is the purpose of using HCN, what is the purpose of using HI, what is the purpose of structural prediction we get by using Br2 water, bromine water, and one more reagent is there. So HCN, HO, bromine water, acidic anhydride, acidic anhydride. So when we use acidic anhydride, we get pentaacetate. That means pentaacetate means 5 OH groups are there, 5 hydroxyl groups are there. Bromine water, we get 1 carboxylic acid group. That means this is a mild oxidizing agent. That means it oxidizes CHO, it oxidizes this the 1 CHO group that is present to COOH. That means the presence of 1 aldehyde group. Okay. That is there. HI means HI. When we treat glucose with HI, what happens in that case? In that case, we will get N-hexene. We get N-hexene. N-hexene means that all the carbons are in a straight chain. Okay, all carbons are present in straight chain. Straight chain. Okay, HCN. When we treat with HCN, so HCN in that case we get hemiacetal. Okay, that means it shows that there is a presence of carbonyl group. Okay, ma'am, increase your voice rate. Okay, bachas, I think from my side it is done. You go and calm down, relax. Okay, all the best. You got this. You have learned, you've done the hard work. Okay, now the part is there, you have to do your best, solve the questions, focus, read the question twice, okay, and then answer it. Okay, you got this, trust me, because I have seen you guys working hard with me. Okay, I've seen you guys solving questions with me, so I know you got this, so you can do this. Okay, still the exam is starting around like after 2, right? Yes. Okay. 1 second. Polymers questions are not there. That's not in your syllabus. 1 second. Any doubt you have? I've done all the PYQs right now. At what time should we be there? Your exam, you should be there inside like around 2, you should be there, right? One second. No, I have explained organic. Yeah. Ma'am, biomolecule reactions. Well, let me check once again if there is any reaction that is left for biomolecule. Biomolecule. Just give me 1 minute, huh? Biomolecule questions I did though. This is one biomolecule. I can explain little bit about chapter, I think. Okay. Give me 1 second. I'll just explain the chapter, I think. Yeah, I'll just explain what thing I think is necessary from biomolecules. I have noted down somewhere. Just give me just 1 second. Huh? fine. You guys have doubts on biomolecules, right? Okay, one second. I did explain, but it's okay. I'll just explain biomolecules. Yes, 1 second. Okay. Okay, so in biomolecules we have carbohydrates, proteins, enzymes, vitamins, nucleic acids and hormones. So we will be doing with the portion that majorly questions were being asked. Okay, so we have okay, I have explained you the reaction. These reactions are important, right? What is the purpose of each of these? Structural determination. Okay, now after that structure ho gaya. HNO3 is also there, right? Elimination. Okay, alpha glucose and beta glucose. What is the difference between alpha glucose and beta glucose? So they depend different in the position of the OH group. They differ in the position of the OH group. Okay, for alpha it is down, the OH group is down. For alpha for alpha glucose this OH group is down, and okay, and rest positions are all same. CH2OH, this OH down, up, down, OH. This is alpha glucose, this is alpha D glucose. Okay, and for beta D glucose you just have to do, you don't have to do anything much. Okay, OH group is upside. Only at this carbon the configuration is different. That's why they are called anomers. They are called anomers. When they have same configuration but the configuration only on one carbon is different, they are anomers. Okay, so the rest is same. CH2OH. Okay, we have OH here and OH here, and this OH is downstairs. This is your beta glucose. This is your beta glucose. Okay, structure is important. Again, beta in between alpha and beta glucose is higher melting point. This is higher melting point than beta D glucose. Okay, okay, one more thing, this is there. Okay, yeah, sucrose, maltose and lactose. I'll tell you one more thing. Sucrose, maltose and lactose. Sucrose, maltose. So remember, alpha means the OH group is downside, alpha group is OH group is down, and beta means the OH group is up. Okay, then you have sucrose, maltose and lactose. So in this case the linkages are very important. In this case the linkages are very important. So in alpha we have glucose and fructose, right? Sucrose we have glucose and fructose, right? That one thing is important, that after hydrolysis the sucrose becomes levorotatory because of the more contribution of fructose. Fructose is levorotatory. Okay, that is one. In linkages we have C1 and C2, alpha D glucose, C1 of alpha D glucose, okay, and C2 of beta D fructose, C2 of beta D fructose. Okay, that is a linkage, glycosidic linkage. We have C1 of alpha D glucose and C2 of beta D fructose. Here we have C1 and C4 of your alpha D glucose. C1 and C4 linkages of 2 alpha D glucose. It has 2 alpha D glucose units. Okay, that is your maltose. Maltose have alpha linkages, C1 and C4 alpha D glucose linkages. Okay, then you have beta lactose. Lactose have galactose and glucose, alpha beta galactose and alpha glucose, beta galactose and alpha glucose. The linkages are in this case the linkages are your C1 to C4 beta linkages, beta C1 to C4 linkages, beta C1 C4 linkages. So beta C1 beta galactose linkages, C4 alpha glucose linkages. Okay, so again sucrose has C1 to C1 C2, C1 alpha D glucose, C2 beta D fructose linkages. Maltose have 2 glucose units, so C1 to C4 alpha linkages is there. In case of lactose you have beta linkages, beta galactose, C1 beta galactose linkages and alpha C4 alpha glucose linkages. Okay, that is one. Okay, hydrocarbons is not. Okay, again this is non-reducing sugar, and this is reducing and reducing. That means when you treat with Fehling test they will give a positive Benedict and Fehling test. Okay, whenever they have an open CHO group, that is one. Okay, inversion is there. Okay, then you have starch is important. In starch you have amylose and amylopectin. These are the important unit of starch. Okay, amylopectin. I'm sorry for the bad handwriting. Okay, so in case of amylose, what do we have? In case of amylose has C1 to C4 alpha linkages, and in this case we have C1 to C4 alpha linkages and C1 to C4 alongside C1 to C6 alpha linkages, Okay, both are there. In amylose we have C1 to C4 alpha linkages. In amylopectin you have C1 to C4 and C1 to C6 alpha linkages. Okay, that is there. This is around 15 to 20% part, and this is around 80 to 85%. In starch this is around 80 to 85%. This is 15 to 20%. Again, this is water soluble and this is insoluble. This is water soluble and this is water insoluble. Okay, This is important. Okay, amylose and amylopectin, this is majorly, most of the time they ask it. Okay, that is there. Okay, after that you have cellulose and glycogen also. So cellulose and glycogen, cellulose and glycogen. So cellulose is nothing, it has beta D glucose in it. Cellulose have beta D glucose in it. So in this case also you will have beta glycosidic linkages. You will have beta glycosidic linkages, which is C1 to C4 beta glycosidic linkages. Okay, that is there, and it is present in, cellulose is found in cell wall in plants. Cell wall in plants, that is found in cell wall in plants. Okay, then you have glycogen. In case of glycogen, glycogen is found in animals. It is normally found in animal body. It has what? It is similar to amylopectin. This is similar to amylopectin. Remember this. This is similar to amylopectin. That means it also has your C1 to C4 and C1 to C6 linkages, but it is more branched. This is more branched, extensively branched, you can say. Extensively branched. Okay, this is extensively branched. That is your glycogen. This is found in animal body and this is found in plant body. Animal body and this is found in plant body. Okay, that is one. I think you all are gone. Thank you, all the best, bye bye, tata. Okay, yes, okay guys, okay, tata. I think, yeah, we can end it now. Okay, thank you everyone. Yes, Joe, all the best, do your best. I am counting on you. Okay, take care, bye bye.